Good morning. Thank you for joining us for this presentation. I'd like to begin by respectfully asking you to acknowledge the Wurundjeri and Bunurong peoples of the Kulin Nation, the traditional owners and custodians of the land on which we're meeting today, and to pay respects to their elders past, present, and emerging. A little bit of housekeeping before we get started. We are recording today's session. You'll notice that your microphone is muted. That's due to the size of this session. It's important we don't have many people all talking at the same time, so to avoid potential confusion, if you have any questions, please use the chat. So if you move your mouse to the bottom of your Zoom screen, you'll see there's a little chat button. If you click on that, then you can type questions in. So please do ask questions as you have them, and we'll answer them in due course. We know that you may have questions about the impacts of COVID-19 on the university. Could you please check the fact sheet on the website first, as there is a lot of information available there. Thank you for choosing to attend today's session. We're delighted to have you all with us and trust that everyone will support the delivery of an engaging session in a respectful environment. From self-driving cars to the ability to talk to our phones and have them understand us, data science is changing the world we live in. These changes just haven't been to our personal life, they've changed every aspect of society. So one example is if we look at the top 10 public companies by market capitalization in the world, the top 7 out of these top 10 are tech companies, and one of the major sources of the extraordinary wealth of these companies is their use of data science. In particularly Alphabet, which is the parent company of Google, Facebook, Tencent, and Alibaba. The basis of their business is understanding us, their customers, and capitalizing on that understanding. But what is data science? Well, the secret sauce of data science is a thing called machine learning. And to make that simple to understand, what it's about is observing what has happened in the past and working out how to replicate that into the future. So for example, the way in which your phone is able to understand what you say when you talk to it is by having applied machine learning to many examples of mapping the sounds that we make when we speak onto the words that they mean. Machine learning is used widely in social media. So in TikTok, for example, they use the likes and the other actions of the users to work out what content you're most likely to enjoy watching. And the self-driving car learns from situations and the responses actual drivers take, what the appropriate action to take is. Now, all this sounds very mystifying, but what I'd like to try to do now is to demystify that by giving you a very simple example of one of the most simple machine learning techniques. This is a classic technique called decision trees, and I'm going to illustrate that in the context of that terrible disaster, the sinking of the Titanic. Now, I'd just like to forewarn you that I'm going to talk a little bit about the film Titanic. So if you don't want to know how that film ends, then you might want to just take this moment to go and make yourself a coffee instead. So spoiler alert. So what we're interested in is being able to understand the probability that somebody on that ship on that fateful night would have survived. We know all of the passengers and crew who are on board. We know some information about them, and we know who survived and who didn't. And if we pull all of that data together, then we are able to predict for any one person there was a 40% chance of surviving. 40% survived, 60% perished. Now we know for everybody their gender, their age, how much they paid, and what class they were travelling in. So what decision trees do is look at all of the data. They tried dividing it up by gender, so look at the males and the females and how many of each of those survived. They look at the older people, the younger people, those who paid a certain amount, those who paid less, those travelling in first class, second class, third class, and crew. And they see which one of those best helped you divide those that survived from those that didn't. And it turns out that the one factor which was most predictive of survival was gender. So of all of the women on board, 75% survived, but only 20% of males. And now we can repeat that trick. We can take all of the females on board and divide them up by age, divide them up by the fare price, divide them up by the class of travel. When we do that, we find that the factor which best separates the females on board into those who survived and those who didn't is the class of travel. So females in first and second class had a 95% chance of surviving. Females who are travelling third class or in the crew had only slightly under 50% chance of surviving. We can do the same for males. It turns out the most predictive factor there was whether they were a child or an adult. 2/3 of boys survived, only 18% of men survived that fateful night. So now, if we want to look at somebody on board and predict whether they were likely to have survived, such as the fictional characters played by Leonardo DiCaprio and Kate Winslet, we can feed them through this decision tree. So Kate's character was a female, so things are looking much more positive for her than for Leonardo's character, who's a male. Kate's character was travelling in first class, so things now look extremely good. While he barely looks it there, to me at least, Leonardo's character was an adult. And so we can see that you could actually save yourself the trouble of watching the movie because the final outcome is pretty much predetermined. Leonardo's character has very low chance of surviving. Kate's character, very high one. A few minutes of data science could save you the trouble of watching the film. Data science has really taken off in the past decade, so much so that data scientist was proclaimed the sexiest job of the 21st century. You might ask, why has that happened now? Well, it's really due to what I call a confluence of exponential growth. With increased use of information technology, the amount of data being collected is growing very rapidly. In fact, the amount of data collected by humanity doubles in total every 2 years. So, for example, all the time we spend online, lots of information is being collected about all of the actions that we take there. With more and more satellites, there's much more information about the Earth's surface being collected. The list just goes on and on and on. So there's much more information to learn things from, but there's also been a massive increase in the processing power of the computers that we're able to apply to learn from that data. So every 2 years, the power of a new computer approximately doubles, becomes able to process twice as much information in the same time. But that's not the end of it. Also, the number of these computers is approximately doubling every 2 years. So not only is every computer twice as powerful, but there's twice as many of them. So we now have an unprecedented amount of information available to us and an unprecedented amount of computational power, which is able to learn and understand the fine details and apply it to do the amazing things like self-driving cars, like a phone being able to understand when you speak to it. A question you might be asking yourself, however, is data science pandemic safe? So much of our lives has changed in the past 6 months. At the start of this year, the LinkedIn Emerging Jobs Report ranked data science number 3 out of all job categories, after AI specialist and robotics engineer, so data science-like activities. And there was a roughly 1/3 per annum growth in demand for data scientists. But has that changed? Well, you might have heard that many tech startups have been folding recently. So the things like what Google and Facebook grew out of, many of those are finding it hard to find investors in the current environment. And many of those use data science, but they're only very small employers. They don't employ large numbers of people. It's the big players that employ the huge numbers of data scientists. And over the past 6 months, high tech has boomed, as shown by those market capitalizations. Online is one of the things that has really taken off and, if you like, been promoted by the pandemic. So all in all, it has to be considered that, if anything, the recession which is likely to come after the pandemic is likely to drive further demand for data science rather than less. So, if you're interested in studying data science and artificial intelligence, there's no better place to come than the Faculty of Information Technology at Monash. And here is just some of the many amazing academic staff in our faculty. A few examples of the real-world impact of our staff. So I'm a technical advisor to the BigML data science platforms. This is a commercial online data science platform which allows you to do all the things you might want to do in data science. In fact, I was the person who invented and realized the association rule discovery component of that platform. I'm also a technical advisor to a European recommender system startup, Frumal, a system that, for example, for one daily newspaper, for each reader, works out what are the articles which are most likely to be of interest to them and helps lay out the front page accordingly. One of our staff, Professor Din Feng, is the technical director of Trusting Social, which is a system which helps people who don't have credit scores gain access to credit. So people are caught in a kind of catch-22 that you can only gain credit if you have a credit score, and you can only get a credit score if you've shown that you're a reliable person repaying credit. So what Trusting Social does is use other sources of information, such as repayment of phone bills, to identify the credit risk of individuals, largely in the developing world, to provide access to credit for many individuals who otherwise would not have it. A number of us are involved in an initiative called Fungal AI. So a very serious problem in our hospitals are fungal diseases. Indeed, one of the large hospitals in Melbourne spends several $1 million per annum on antifungal medications. But for reasons that I won't go into, they don't actually track who has fungal diseases. So what Fungal AI does is use machine learning to be able to identify in retrospect which patients have had fungal infections. So we're able to understand how well the medicines are being applied, able to identify at-risk groups and improve medical treatment. Another example, led by our Dr. Campbell Wilson, is a joint initiative with the Australian Federal Police on using artificial intelligence for information forensics. So, for example, they've developed techniques which are able to identify illicit images on computer hard disks, potentially saving Federal Police officers the trauma that some of these images can provide if they have to try to search them individually. So I hope that's whetted your appetite for data science. Find out more, head across to the booths or look at our online information sources. We have a data science specialisation in our Bachelor of Computer Science. There's a Bachelor of Applied Data Science. We have a Graduate Diploma of Data Science and Postgraduate Master of Data Science. If you have any questions, please enter them into your chat button now. So one of the questions is there a difference between data science and information technology and the applied data science degree? So yes, these are quite different degrees. So the applied data science degree has some overlap, but the data science degrees in information technology provide computer science qualification, so become a qualified computer scientist specializing in data science. The applied data science degree has similar data science content, so some of the content is shared. You learn some computer science, but you also match that with applications, with specialization in other areas. So you learn how to apply data science in, say, the sciences. Can you do a law and data science double degree? Is another question. And I see Lisa's already answered that. Yes, there is indeed a law computer science double degree, and you could do that and do the data science major. Any more questions? What are the requirements for the Bachelor of Data Science? So it's a Bachelor of Computer Science with a specialisation in data science. Rather than trying to answer that off the top of my head, I suggest you head across to the booth and ask the course advisors there. So if you're wanting more specific course information, join us in the auditorium today for course information. Learn, Grow and Succeed with a Monash Bachelor of IT or Computer Science at 1:30. And there, Dr. Matt Butler will explain all of our courses, or alternatively, go to one of our booths for more detail. What did I mean by the other applied uses? So this is with respect to the Bachelor of Applied Data Science. Applied uses, I had my data scientist hat on, in which anytime we use data science in some other area, we think of that as an application of data science. So the idea behind the Bachelor of Applied Data Science is you study data science and you study some other specialization. And then you use that, you learn how to use the data science in that other specialization, such as biology, for example. Do you need to have foundations in IT to do data science? Certainly, data science requires very strong IT skills, but to do the degree, you're best off finding what the requirements are to enter that by heading across to the booth or going to Dr. Butler's talk at 1:30. Do you have to be good at math to do data science? So there are many different flavors of data science. If you want to be one of the specialists who, so maths is always going to be helpful. If you want to be more on the applied end of data science, so if you want to learn how to use data science to solve practical problems, there's less of a need for advanced math than if you want to learn how to develop new data science technologies. And programming experience is certainly extremely useful because a large part of data science is manipulating the data, and the best way to do that is to write programs for doing it. But that's all something that you can acquire within your degrees. So I think we might have come to the end of our questions now. So with that, I'll bring this session to a close. Thank you all very much for your interest. I wish you good luck in finishing your studies if you're at that stage of things. It's a very challenging time, I know. And look forward to seeing you next year, perhaps. Thank you.